So there are two primitive rules of proof for the disjunction. One of them is wedge elimination, also called disjunctive syllogism. If you have a disjunction, at least one of its disjuncts must be true for it to be true. So a true disjunction must have at least one true disjunct. Suppose you also know that one of the disjuncts, say the left one, is false. So either P or Q is true, but it's not the case that P, then it must be the case that Q. If a disjunction is true, but its left disjunct is false, then its right disjunct must be true. And of course, same for if the right disjunct is false, then the left disjunct must be true. So this is a two-line rule because by itself the disjunction doesn't have enough information in it to conclude that the left disjunct is true or the right disjunct is true. Either P or Q, therefore P, that's not a valid sequent. And neither is that. From the truth of the disjunction, the truth of either disjunct does not follow. You need more information. And specifically, to know from the disjunction that its right disjunct is true, you need to establish that the left disjunct is false. So these two sentences together entail the conclusion. Either P or Q, but not P, so Q, either P or Q, but not Q, so P. If we have a long disjunction, here you have a disjunction with an atomic sentence as a left disjunct and a disjunction as the right disjunct. So, if you have that as one of your assumptions and another of your assumptions might be not A and not B, well, you can prove C here because you can use wedge elimination twice in order to prove C. So first we take out not A from 2, that's 2 ampersand elimination. Yes, there's enough information in a conjunction for you to conclude that its left conjunct is true or its right conjunct is true. So ampersand elimination is a one-line rule. From the conjunction, the truth of the left conjunct follows. Now, not A is the denial of A, it's the negation of A. So 1 is a disjunction with A as its left disjunct, but 3 is the denial of A. And so from 1 and 3 together, by wedge elimination, we conclude either B or C, the right disjunct. Yep. Here's a disjunction, here's the denial of the left disjunct of that disjunction. Those two together prove the right disjunct of the disjunction. And the assumption set here will be 1 and 2 because 1 rests upon itself, it's an assumption, and 3 rests upon 2. So now we've got either B or C, then we can take out not B, the right conjunct, from 2. So that's again 2 ampersand elimination, and we're taking out the right conjunct this time. And now 4, 5, wedge elimination gives us C. So two instances of conjunction elimination, ampersand elimination, a one-line rule, because there's lots of information in the conjunction, and two instances of wedge elimination, a two-line rule, because from the disjunction by itself you can't prove either disjunct, but if you have the denial of one disjunct, then you can prove the other. So that's wedge elimination, also often called disjunctive syllogism. The other rule, wedge introduction, is puzzling but clearly truth preserving. From any sentence, P, let's say, you can truth-preservingly conclude a disjunction with that sentence as one of the disjuncts, whether it's the left disjunct or the right disjunct. If P is true, then either P or Q must be true, because this just says at least one of the disjuncts is true, and if P is true, then at least one of the disjuncts is true. And the same for if P is true, then either Q or P is true. Where does Q come from? Out of logical space, out of nowhere. And you might think this will lead to trouble for us, but it doesn't actually. Provided we're careful, we can never be forced to go from true to false by this rule. This rule is a truth-preserving rule, and it enables us, whenever we have a sentence, to form a disjunction with that sentence as one or other of its disjuncts. So those are the two rules related to the vowel, and wedge introduction is not a rule that we use a lot, but there are quite a number of situations in which it's helpful. For example, suppose you have a conditional that has a disjunction as its antecedent. So this says if either A or B, then C. And we have our second premise tells us A is true. So obviously C must be true, right? Because line 1 says if either A or B is true, C is true, and line 2 tells us A is true. So then we use the wedge introduction rule to wedge introduction to give us either A or B, and that's definitely truth preserving. And then because either A or B is the antecedent of the conditional, we can do arrow elimination, modus ponens, 1, 3, and that gives us the consequent of the conditional. There are other places where we use wedge introduction, particularly in theorem proofs, and we'll get to those in a little while.